So we're going to go ahead and get started with our first presentation, which will be presented by Yongkwan Kim from KAIST in Korea. And also before we start, I'd like to note that this paper did receive a Best Paper Award from KAI. They're one of the KAI Best Papers, so we do have their certificates for you and your co-authors here. So congratulations to Yongkwan Kim for a Best Paper Award.
Right. Thank you for the nice introduction. So let me begin. In this morning, I woke up and brushed my teeth, took a shower, dried my hair, shaved, ate breakfast, drank coffee, watched TV, checked emails. We live surrounded by a lot of handheld products. Such products should be designed carefully to be grabbed and used by our hands. When designing such products, designers need to sketch products with hands together. By doing so, the designers can consider the scale and proportion of the sketch. Without drawing hands, final products might be out of scale or proportion. So, however, many designers don't draw hands because it's difficult and time-consuming. So in 2016, we proposed sketching with hands, a 3D sketching system incorporated with a hand tracking sensor so that designers can sketch products with hand information but without having to draw hands. After presenting this work, we took one step further. How can we make designers express scale and proportion of products larger than handheld sizes, such as a coffee maker? In fact, we are good at describing shapes with our hands. So I will describe this coffee maker with my hands. There is a sphere, there's a body, there's a little thing on the top. Easy, right? And now it's your turn. I will show you a product and try to describe it with your hands. Get ready. Go. Okay. Yeah, so many wavy hands. Yeah. See, we can do it. So many others try to utilize this power of hand motion to create 3D sketches in the air. However, the results are too rough, so it's hard to be utilized in product design. They looked rough 17 years ago and still rough today. I would say this is not because of the technology, but because of the nature of our hand motion. To summarize, hand motion is rapid but rough, and pen drawing is delicate but tedious. By combining these two inputs so that each strength are reinforced and each weakness is resolved, we present a new 3D sketching workflow, Agile 3D sketching with Air Scaffolding. Let me show you a live demo. Okay. You can see my hands. So this is the 3D sketching system with a graphics tablet and a pen and hand tracking sensor. So on the screen, there is a virtual 3D space, so I can navigate this space with a pen and button. And tracked hands in the air are visualized as circles on the screen. And this time, I will make a new concept of a steering wheel. So first, I will express the grips of a steering wheel. So I can create rough 3D volumes in my hand motion. We call this technique air scaffolding. And the created curve networks, we call these air scaffolds. So I can set a sketch plane on scaffolds by applying a short pen strokes over the scaffold curves and I can draw curves on it. And also, I can set a sketch plane on the existing curve to create a section sketches for the grips. And at any time, I can add more scaffolds. So the hand gets closer to the sketch, green circles appear so that I can get spatial sense and revisit the workspace. So I'm gonna express front panel of the steering wheel. See? Then I can continue to sketch. More section curves. And I'm going to link these grips with the main body. See, without scaffolds and with scaffolds. So I could create a 3D concept of a steering wheel under 5 minutes with combining hand motion and pen drawing. This is the end of my demonstration. Thank you. And let's take a look at each function in detail. When designer moves his hand in the air, only the descriptive hand motion remains as scaffolds. To achieve this, there are challenges in identifying meaningful hand motion. So these are full trails of designer's hand motion. It's too messy because unintended hand motion is captured during transit between intended shapes. An intended shape might be overpopulated when visited by hands multiple times. To solve these problems, we devised a method to create only intended and neat shape with natural hand motion without any mode changes. So here's the designer's hand, and to better deliver our concept, I will bring one metaphor, which is considering hand as an imaginary 3D printer that sprays heated material in the air to create 3D shapes. So now, if the hand starts to move in the air, the hand sprays material in the current position. When the hand moves, the hand sprays material along the path. These materials slowly disappear over time unless it's collected in sufficient quantities. Now the first material left is almost gone. This time I will move the hand in the opposite direction. As the hand revisits some parts of the previous path, it sprays additional materials into the same space. When the amount of material becomes large enough, it becomes solidified as a scaffold curve. So the only repeatedly visited areas remain as meaningful shape. The solidified curves do not degrade over time, but if the hand repeats movement in the near position, the hand melts the existing scaffold curves and recreates the new scaffold curves. So this ensures that scaffold curves are not overpopulated and can be constantly modified. So in the end, the near curves are connected to each other to be used for later pan drawing. Through this process, from the captured raw data, only the intended shapes remain naturally, and the designer can use the scaffolds for more detailed pan sketching. In this case, a sewing machine. So for more details about our air scaffolding algorithm, please refer to our paper. So now the designer can set up a sketch plane by applying short pan strokes over the scaffold curves and draw curves on it. And unnecessary scaffolds can be erased. And with the help of visualization of contact information, the designer can add more scaffolds by revisiting the workspace. Let's see some examples. These are my very first sketches after I implemented this system. And rough scaffolds were used for considering size and proportions of the lamp, and details such as the joints of the lamp were added with the pan drawing. Shapes with large curvature, like this top of the skate, can be expressed with rounded hand postures. And shapes with small curvature, like these four arms of the drone, can be expressed with curled hand postures. And geometric shapes with boxes and cylinders can be expressed, and more organic shapes, like this flower, can be expressed with natural hand motion. Is that only me who can sketch like this? To answer this, we evaluated our system through 10-day sketching sessions with 12 designers. These are results from the designers. And 85 concepts were produced from total 50 hours and 51-minute use time. During the sessions, there were no limits on type or number of concepts and use time. After the session, the participants rated that the strongest merits of air scaffolding is defining scale and proportion quickly and accurately. Now let's take a look at their qualitative feedback and their sketch outcomes. First, air scaffolding was easy to learn. One said, you don't need to learn to express shapes with hands, and you already experienced. And air scaffolding enabled designing products in real scale. Participant sketched a camera and said she could almost grasp the camera. Another sketched a vase with air scaffolding on the left and without on the right. She said the scale of the vase with air scaffolding was okay to put flowers in it, but the one without was too small. Air scaffolding kept 3D sketching in proper proportion. In 3D sketching, it's important to maintain the proportions in all viewpoints, not just in a single view. And one participant confirmed that the scaffold ensured right proportion from other directions during sketching. In this example, with scaffolds, the left scooter was drawn in correct proportions, but without scaffolds, she failed to draw the handles of the right scooter at the proper height. See? Air scaffolds eased locating sketch planes in any orientation. As you have seen in my demo, setting sketch planes in desired position and orientation is crucial to the quality and performance of 3D sketching. So participants could utilize scaffolds to get reference points in the air and set sketch planes in various orientations which are not limited to horizontal or vertical surfaces. In this example, first, on the left, her constructions were limited to orthogonal sketch planes. But later, she could create more organic shapes by drawing curves freely using the scaffolds, as you see on the right. Air scaffolds made 3D sketches minimal. It's easy to lose the sense of the whole when drawing a part, but with the scaffolds, the participant could approximate the overall shape first and then start drawing partial details on the scaffolds without having to draw unnecessary construction lines. So in this example, compared to her first sketches on the left, we can see that the participant could reduce the unnecessary section curves in later sketches on the right. And air scaffolds stimulate new ideas. Scaffolds are like the clouds in the sky, so that designers could find various shapes they didn't expect. And one participant actively utilized this characteristic to sketch 3 different forms of a handheld vacuum cleaner started from the same scaffolds that she created. And to conclude, we propose a 3D sketching workflow combining the strengths of hand and pen inputs. And we devised an algorithm to construct air scaffolds by identifying descriptive hand motions from transitory. And we developed a practical system by integrating air scaffolding with pen-based 3D sketching. And we conducted an in-depth long-term user evaluation. And finally, we showed that our system facilitates designers' agile idea exploration in their real design workflow. This is the end of my presentation, and see you soon at our demo tonight. Thank you.
Hi, Fabrice, Preferred Networks. As far as I understand your scaffolds, they're not interacting with the pen task, right? They're just there to basically provide the proportions, as I understand.
Just the scaffolds works as a 3D reference for creating a sketch plane.
But so would it be possible to use them also as kind of guides in any way? So when you draw with the pen, maybe you can have not a snapping function necessarily, but when you draw a curve, then they would maybe try and follow the general shape of the scaffold.
Yes. Actually,
so they could actually be tightly integrated and be used mutually.
Yeah, it's currently not integrated, but we think that the rough 3D volume information is very rich information to utilize for further design process to deliver some surface information. But we currently focus on early idea exploration stage. So in the next step, the scaffold data can be further processed into some surface information with the curve sketch together. Yes, thank you.
Hi, thank you for the presentation. So this is Seok-Hyung from Shopify. So it just seems like the gesture that are used in the studies are with the entire hand. I'm just wondering, while you're observing people using it, have you noticed anything kind of like people using fingers or partial of their hands instead of the entire hand? Because it's not, I guess it's not something that I, as a designer, would actually expect to see a lot, right? But I've seen people using hands pinching. Just curious about the gestures.
Yeah, that's a good suggestion, I think. And we focused on role division of 2 inputs. So mainly, hands works as a rough volume making function, and pen drawing works as a precise detail drawing. So we intended to divide roles to different inputs, but more finer detail with hand gesture might be good integration to our system. Yeah, thank you.
Neil Maiden from City University of London. Do you have a sense of the level of expertise that this tool, in terms of designing, that this tool is ideally suited for? Would you expect architects of 30, 40 years experience to benefit from this tool, or is it someone who is in the early stages of their career?
Actually, our evaluation user was a university student. He majored industrial design and used various 3D modeling tools and digital drawing software. So I expect that from the beginner to a professional beginner, but to expertise with many years, might be our target users. Basically, someone who can draw in perspective drawing, they can use our 3D sketching system easily. Yeah,
Thank you.
I see. Yeah. Thank you.